البوط، ولكن البوط قلت لك غنديروا البوط فقط. هذا هو شحال اللي كنعرف. الدراري غنبداو راه غيبداو يلا. يلا الدراري راه غيبداو. راه غيبداو. راه غيبداو. Hello, I'm so high. I'm high.
Ah, c'est une secte, hein. C'est une secte.
Là, on croit, on dit attends, une frérie. Vraiment, j'ai mis. We are waiting for people to come in. This game will start. I think they will activate it now. I think the two of them are working. أما البلايصة طلع البلايصة. عزيزي خرج جيب عباد الله. خرج عيط على عباد الله والناس جلست هو المراكشي. خرج عيط على عباد الله جيب قول لهم راه دايرين طنجيه لداخل والله تيجيو. On commence, c'est bon? Tu penses? So we'll start after the break with our fourth speaker of the evening. And I will introduce Jemima from, she's coming from London. She's a self-taught front-end developer and also a Google developer expert in web technologies. So a big applause for her. Bon courage.
Great, thanks. Real quick, mic check. Can everyone hear me all right? Excellent. Let's get into it. Hi, everyone. My name is Jemima, and today I'm going to be talking to you about building accessible components in React. So just to introduce myself a lot, because I am my favorite subject, and I do like to talk about myself. So like I said, my name is Jemima Abu. I am a front-end developer, a Google developer expert in web technologies, a Microsoft MVP in web development, and a certified professional in accessibility core competencies. Basically, what that means is you guys are in good hands for this talk. You can find me online anywhere at Jemima Abu, so that's Twitter, LinkedIn, GitHub. That is my handle. Let's get into it, building accessible components in React. First of all, I'm going to talk a bit about what accessibility is and why it's important, and then we'll get into the hows of building accessible components. So what is accessibility? Simply put, accessibility means something that can be used by everyone. So if I say something is accessible, that means I'm able to use this thing. Oftentimes, we have to make special, how do I put it? Like special conditions to make sure everybody can use this thing in the same way. For example, you can have curb cuts on the road. That means people with wheelchairs or crutches can use this. Thank you. All right. For example, you can have curb cuts. That means people with wheelchairs or crutches can use the roads easier. You can have brailles on elevator, meaning people with visual disabilities can use them. You can have push-to-open buttons or ramps. That means people with wheelchairs can get around. So basically, accessibility means building something that everyone can use. And as developers, it's very important, or frankly, as people that build products, whether you're a developer, a product owner, a product manager, a designer, it's very important that when you're designing or developing your product, you're thinking, how is everybody going to use this thing, not just how does this thing work for me? For example, there are 1.3 billion people in the world that have some form of disability. This means that if you are creating products that not everyone can use, you are alienating 1.3 billion people, or 16% of the world's population. Disabilities can also be situational, permanent, or temporary. This means that disabilities are not just something you are born with, they are something that can happen to you, or something that can be temporary in that moment. For example, I use glasses because I have very short, very bad eyesight, because I used to sit directly in front of the TV when I was a child. So, don't do that. But basically, without my glasses, I can't see like my slides in front of me or anything. So my glasses are a form of assistive technology. These are the different kinds of disabilities that people can have. It may not just be something that is obvious to you, it's just things that work differently for people. Another reason that accessibility is very important, apart from the fact that you should be building things that everyone can use, it's that it's the law. So Morocco has its own law on building accessible or making sure things are accessible. So what happened was that they actually adopted the United Nations Convention on Disability. And basically it states that people who have any form of disability should not have to face any barriers towards achieving a goal or something. So each country has its own different law. The US has its own law, the EU has its own law. But at the end of the day, the fact is if you keep building things that not everyone can use, you're gonna have to use this sticker on Microsoft Teams, and you don't want to be the one explaining to your product manager why you have a lawsuit because you didn't publish something that was accessible. And yeah, that's pretty much it on a little overview on what accessibility is and why it's important. Up next, we're going to talk about React and accessibility. So just quick show of hands, do we all write React here? Okay, all right, that's a front end in general, maybe not React. I'll take it. Let's begin. So, React and accessibility. There's a very funny quote I saw online where someone said accessibility is like a blueberry muffin. I don't like blueberry muffins, so I changed it to banana bread because I love banana bread. So basically, accessibility is like banana bread. What does that mean? Now, imagine you go to a cafe and you order banana bread, and then they give you a slice of bread with bananas on it. You're gonna be like, what the heck? That's not what I ordered. I ordered a banana bread. That's exactly how accessibility works. It's not, you can't take a complete website, throw a bunch of ARIA labels on it, and say, okay, I have an accessible website. That's not how it works. You have to start building it from the ground up, the same way you mix your flour, you blend your bananas, you bake it in the oven. Yeah, that's how you make banana bread. The same way you have to build an accessible website. You have to start from the beginning and then make your way to like the final result. And now, finally, accessibility can't be an afterthought. That's basically saying that if I am building something to be accessible, I can't put it at the end. I can't say, okay, now I'm done building my website, I'm going to make it accessible now. You have to build it from the start. And that's basically what this talk is going to focus on. We're going to look at how we can make sure that the React components we're building are actually accessible. So let's get into it. How to build accessible React components. The first thing, and I call these fundamentals because I like to say for me, these are like the basic blocks of building anything that is accessible. So let's start with React. React is a single page application, right? So anything you build in React, it works in a single page layer, meaning that it's just loaded on one page. You're not loading different HTML pages the same way regular websites work. The issue with that is because React is not loading different pages, users are not interacting with a React website in the same way they are reacting with other websites. So the first issue to look at is the title tag. When you're using React, because it's just reloading the page, you're not actually updating the title anytime because technically it's still the exact same title you're showing your user. So if I have 10 million React tabs open, they're all going to have the same title. Now imagine if you walk into a bookstore and every single book had the same name. And you're like, oh, can I read that one really good book that I like? And it's like, good luck finding it, because you have no idea, because everything has the same name. It's similar with putting titles on your application. You want to make sure that you are giving your applications the right title once you're loading them. And it's very easy to do this in React. You can just pass your useEffects hook and pass your document.title. And I think in React 16, I want to say the updated React version, they have a feature where you can just use the title tag anywhere in the code and it adds the title for you. That's a very good thing to look into. Secondly, we have maintaining user preference. So now, I don't know about you guys, but personally, I like to doom scroll on my phone a lot. So if it's 1 a.m. and I'm scrolling on my phone and I open a website that has light mode or something, I'm going to be in a lot of pain because my eyes are not used to that much brightness at that time of the day. That's another feature you want to keep in mind when you're building something that is accessible. You want to make sure you're providing options for your user to match what works with their requirements. So for example, like iPhone has an automatic color scheme where if it gets to like 6 p.m., it automatically changes to dark mode. So if I was building something and I wanted to make sure that, okay, if the user's phone has switched to dark mode, my website should also be on dark mode, I would just use like the hooks to set the state to match the user's media. We have these features called match media preferences, which basically take media queries that are according to what the user prefers. So the one I'm using here is match media preference for prefers color scheme dark. You have multiple media preferences you can match, such as prefers reduced motion for users who don't want a lot of animation on their sites, or prefers contrast for users who want like more intense darkness on their websites. So these are just some simple ways that you can make sure you're taking your users' preferences into account when you're developing your websites. And then finally, getting to the point. So here we have a page, and it looks like a fairly simple page. It has links, it has a button. So I want to click this button, but I don't use a mouse, I use a keyboard. So now if I was using a keyboard and I want to click that button, I would have to tab through it. So if I start tabbing, and I click tabbing, and I click tabbing, and I realize that there are actually way more links in this page than I thought, and then I just end up giving up because I'm not about that life. So the fact is, when you're creating something, if you're going to have, and then obviously that navigation was an exaggeration, but the fact is sometimes you can have navigations that have a lot of sub-menus or a lot of nested drop-downs, and you want to make sure your user can access your content without having to tab through everything that you're using. A simple way to do that is by using a skip to main content link. So how that works is you just have a button at the top of your page, the user tabs onto it, once they click it, it gives them focus on the main element. And once again, implementing skip to main buttons is very straightforward with React. All you do is assign a ref, and once you click it, you just focus on the button that you want to focus on. And that's pretty much it. It's very straightforward, and that is the useful thing with React. With React, it's easier to write these things than with JavaScript, because with JavaScript, you have to do a lot of document or get element by ID or all of that stuff. But with React, because everything you're building is already in JavaScript, it's easier to just access it from the DOM. Yeah, and there's some styling to handle the hiding the skip to main content link, because we didn't have to use JavaScript for that, which is great. Up next, we have semantics. So now when it comes to accessibility, aside from the fundamentals, you want to make sure that you're also focusing on the semantic layer of your application. And so like I said before, if your fundamentals are going to a bookshop and all the books have the same title, the semantics are the actual content of the book. So for example, if I open a book and I want to go to a chapter, I'm just going to go to the table of contents and scroll through chapters and click on the chapter I want to view. That's exactly how semantics work. Semantics are landmarks that your web page has that makes it easier for people using assistive technologies to get to the content they want to reach quicker. If I was using an assistive technology and I was like, okay, I want to go to the footer because I'm looking for the contact us button and I want to go straight to the footer, my assistive technology would be able to read this page and tell me, okay, footer is here, and then I would go through that. If you weren't using semantics, it would be a lot harder for the user to navigate. So now we're going to look a little into something called the accessibility tree and basically explore what these semantics look like to people that are using assistive technologies. So for example, this is a simple React application. I have my nav, my header, my main, and my footer. You can see here that everything I'm using uses a div. Now, if we go to the accessibility tree, this is a feature in Chrome that allows us basically see what accessibility looks like. You can see that once it toggles, it shows me my layout is set as ignored, generic, and then just static text. Basically, what this means is that to my user doesn't have any context of what the layout of my page looks like. It only knows what the text inside looks like. This is because I was using divs and spans, which are not semantic elements. But now, if we check, I don't know why that's there. I had a funny quote here where it was basically like, not using semantic elements is like ripping the labels off all your cans of food. Like imagine if this is how cans came, and then every time you want to eat something, you had to open the can and be like, gee, I wonder what's in here. That'd be a terrible way to live. So that's pretty much what it's like for people when you don't use semantic elements. But on the other hand, yeah, I already said that. But on the other hand, if you do end up using semantic elements, so here I have rewritten my elements to use my nav, my header, my main, and my footer. Once I go into my accessibility tree, I can see that they are broken down into the right landmarks as they should be. So I have my navigation up there, I have my banner, I have my main, and I have my content info. So that's basically how semantic elements work. Yummy semantics. Semantics are the labels on your can that describe what the content of it is, so people don't have to pop open your cans to get what's inside. And then it comes to the second part of semantics, which is ARIA. Now, ARIA is basically labels that we can use to describe the content of our page to screen readers. So the first rule of ARIA is don't use ARIA. And what that means is if there is a semantic element for something, don't use the ARIA label for that thing when you can use semantic elements. So for example, instead of saying div role button, just use a button. Instead of saying div row dialog, just use the dialog tag. So the fact is, when you have semantic elements that already exist for something, don't use the ARIA labels for them. But then on the other hand, you do want to use ARIA labels when they are necessary. So while on the one hand, I don't want to label my content using ARIA labels, I want to ensure that my content state is being updated correctly using ARIA states. So we have ARIA states like ARIA hidden, which indicates to a screen reader that we don't want this content to be displayed. We have ARIA selected, which can be used for like drop downs or accordions or anything to let the screen reader know that things have been tabbed into. And a really good example of when to use custom ARIA roles is when building a tab component. Because tab components themselves don't have a semantic HTML counterpart, if I was building a tab component, I would basically have to use a lot of ARIA roles to ensure that screen readers could properly understand what's going on in my tab components. And if you check the accessibility tree of your tab component, you see that it's broken down into your tab list and your tab panels. Now, to a regular user, tab list and tab panel doesn't mean anything to me, but if I was using a screen reader or I was using assistive technology, this is the content that I would be looking out for. So it's just things like this that we need to keep in mind when we're writing code. Basically, you want to make sure that you are writing the right code in the right way. Another issue that you may run into when you're writing a React component is sometimes, because React requires you to wrap everything in a wrapper, you may want to end up using a div. So like if you try to render this and React was like, no, it needs to be wrapped in a div, you may want to throw a div on the page and like load that. But the fact is you are adding another unnecessary generic tag. So if in React you only need this content to wrap something, don't use a div, just go with a fragment. It's like a blank tag that you can use and it just does the same purpose as a div of wrapping your code, but it doesn't actually render something that's unnecessary and generic. Yeah, and next we have interactivity. So this is basically using React to make sure that users can interact with our websites in the best way they can. So the first rule of interactivity is that for every mouse event handler, there should be an equal and corresponding keyboard event handler. That means if I am building a custom component, and that custom, for example, if I'm building a tab component, and I want that tab to toggle the buttons, toggle the content based on which button is clicked, I want to make sure that I'm also taking into account people that use keyboards. Because if somebody with a keyboard presses enter, does that thing actually work? If I open a modal and somebody with a keyboard uses the escape key, does the modal close? So you want to make sure you're keeping these things in mind when you're building things. And once again, very easy to check for your keyboard handlers when you're writing your code. You can just use your event key and e.which is equals to 13. So you can use that to check if the user presses the enter key, just carry out the right code. If it doesn't, if you want to check any other keys, you have other options to use for them. And then we have handling modal focus, which is one of the banes of my existence when it comes to React, because there's never a straightforward way to handle modals. So let's look at what appears to be a simple modal on a page. All right? Now, I don't know if you guys can see this, but when I click into this modal, I cannot gain focus on this modal. This is me tabbing through the entire page, trying to focus on that OK buy button. I'm tabbing through all the navigation links up there, tagging through everything, until finally, there, I was able to click the modal. So the fact is, when you're building modals, and this is what that kind of modal would look like if I was building it, I'm toggling the is open button, I'm calling my CSS styles to style it, and I'm making sure that it's clicked and displaying the modal. When you're opening modals, it's not just enough to think, okay, the user clicks a button and the modal appears, that's great. You need to think, what about people that aren't using like the mouse? People that are using keyboards, if they click that button, can they actually gain access to that modal directly? So there are a lot of ways to build accessible modals in React. One of my favorite ways to do it is using a HTML element called popover. So this is a modal that was built with the HTML element called popover. And if we click into this, we see that it opens the modal and the focus immediately goes to the modal where I need it and it closes it immediately. And that really useful thing about using popover is that it's very simple to build. I did not need to write any JavaScript code for this because it uses a HTML attribute. So all I needed to do was pass in the popover equals to auto attribute and the popover target attribute for my button, and that automatically creates a new modal for me. You don't even need to do a lot of styling because it comes with its own backdrop and it comes with its own positioning. So that is one of the ways we can use HTML semantic elements to get inbuilt benefits that we may not get if we're building custom components with React. Another really cool package I would recommend for building custom modals in React is the React ARIA modal. So it's basically, it has all the accessibility features you can think of for a modal, and I think for me, this is the one that I use the most. It's just a modal that makes sure the focus is trapped into that modal until they tab out. So yeah, I would definitely recommend React ARIA modal if you are looking to build accessible models. And then we have accessibility testing. So if you've built your products and you want to make sure that they are, like, they work properly or they are accessible, what are some ways you can actually verify that? Now, personally, when I'm building my websites, I do like to use Lighthouse. So this is Chrome Lighthouse, which is an inbuilt extension in Chrome that helps you test like accessibility or performance of your websites. So this is a website that I tested, a React website I tested, and it returned an accessibility score of 100. But the fact is, this website wasn't accessible at all. Because like I said, I was actually using the divs and I wasn't using the proper landmarks at all. So when it comes to React applications, I wouldn't necessarily recommend Lighthouse, but it's something to keep in mind because using the wrong accessibility testing tools can give you a false sense of security because you think, oh yeah, I've tested this, it's working, that's great. It's not. The best way to test for accessibility is to carry out manual testing. Manual testing basically means you're going through these sites yourself and trying to imagine how somebody that relies on assistive technologies would use these things. So it could be using screen readers. Some screen readers can try out ChromeVox, which is an extension in Chrome, or the Mac VoiceOver, which is inbuilt in any like Mac laptop. It could be testing for keyboard events and focus. So just take off your mouse, tab through the website, see if you can actually navigate through all the parts of your website using only a keyboard. And it could just be checking the accessibility tree. So if you just want to know if the layout or the landmarks or the semantic structures in your website are easy to navigate, just go to Chrome and check the accessibility tree. Another very important fact when it comes to building accessible components is accessibility first development. So what accessibility first development means is you're making sure that accessibility is inbuilt in your website from the ground up. So one easy way to go through accessibility first development is to make sure you are following the WCAG standards. WCAG standards are basically the worldwide rule on making sure things are accessible. So it's making sure your content is perceivable, operable, understandable, and robust. Another one is implementing an accessibility checklist at every stage of development. So this is just really useful for developers. It's making sure you are meeting all your semantics or all the layers of code that you want to get while you're building your websites. And then the last one is just making a deliberate effort to care about accessibility. Because at the end of the day, accessibility is something that we should all be making sure we're taking into account when we're building our websites. Ignorance is not an excuse to say, oh, I didn't know it wasn't accessible, so I don't have to make it accessible. Like, it's kind of our jobs to make sure things are accessible. So that's something you want to keep in mind when you're building. And then, like I said, so using certain extensions might not be helpful because they can give you a false sense of security. But these are some extensions that I would recommend just because I do find them helpful for certain things. So the first is the Axe DevTools extension. So I would use this instead of Lighthouse for Chrome because it does it, like as you can see, it tells you all page content should be contained by landmarks. So it does a very useful job of actually reading the code and returning like the right structure or setup that you should be using. Another tool I would use is the Web Accessibility Evaluation tool. This is actually a website, so you just go there and you put in the URL that you want to test, and then it returns any breakdown that you need, so it can tell you what errors you have or what structural things you need to look out for while you're building. Accessibility audit is also another great one. This one is basically a free audit of your site, so kind of like if you went to an accessibility specialist to ask them for a report, Accessibility offers that on their site for free. You just need to go there, put your website in the link, and it will return like a little report on everything you're doing right or things that you could stand to fix. And then finally, the Web Accessibility VS Code extension. I use this more for HTML builds, but it would be useful in React too, because basically it's anything that uses HTML. So this is an extension that you have built into your Visual Studio Code if you use that, and then it just goes through the code and tells you things that you could stand to fix, like providing an ARIA label there, or making sure you're using assigning a label to an input. And yeah, that's pretty much it. So thanks for listening, everyone. If you do want to check out some more things on accessibility, I have listed some resources here. The Great Accessibility Bake-Off is a really great talk by Cordelia Dillon, and the slides are great too. So I've listed the slides there. Demystifying Accessibility in React Apps is another really cool talk by Katrina. I would recommend checking that out. And then keeping heading levels consistent. I just included that because that is something that I deal with a lot at work. When you have nested components and those components have different headers, it's hard to know because headers should go structurally. So like H1 should follow H2. But if I have a component that has an H3 tag and it's being called before something else, it's harder to keep that in mind. So I would recommend checking out this article called Keeping Heading Levels Consistent with React Context, because I think it's very useful. And yeah, that's about it. Thank you so much for listening, everyone, and I hope you enjoy the rest of the conference.
Thank you. Thank you so much, Jemima. And now we will have our speaker from Amsterdam, I think, and is originally from Egypt, from Iskandaria. I love Iskandaria. I will go there one day. He's a senior software at Miro and the Google developer expert also in web technologies. And today he will share with us his insights. So, big applause for him. وما تنسوش الجد 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 more 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 more. C'est bon, génial.
Thank you very much. Hello everyone. I would like to start with a recognition for everyone behind this event because it's been a lot of things they are doing. Ayman, Elian, and everyone else behind the camera. Please join me with another round of applause for them because they did a lot. Woo! Thank you guys. Cool. Today I'm coming to talk to you about what you need to optimize after React compiler. So I will start with some questions. First of all, who is using React compiler already? Okay, only one person. Who have heard about React compiler? Cool. Yeah, I was going to be skeptical about the right conference. Who's using React? Yes, I would like everyone to raise their hand. Okay, awesome. Cool. Today, it's going to be a little bit lighter than the other talks. Hopefully, we are by the end of the day, so I'm not going to be so deep, but please bear with me so I can be on time, hopefully. A little bit about myself. My name is Madhat Dawood. As was said, I flew to here from Amsterdam. By the way, anyone flew to here other than Morocco? Anyone from outside Morocco? From Africa? Okay, awesome. We have some people. But originally, I'm from Egypt, so I speak Arabic, but I'm not speaking Moroccan, so please don't speak to me Arabic mixed with French, because I don't speak French. Another thing, I'm Google Developer Expert in web performance. If you like what you see today, please feel free to follow me on this butterfly is Blue Sky. It's a new platform. It's full of experts over there, better and cleaner than X. However, I'm still an X as well. So let's dive in. In React Conference 2024, there is two important announcements that I'm really happy with. The first one was the React 19 RC, which has a lot of performance enhancements because I'm caring more about performance. And the other one was React Compiler. It was announced as experimental, and they made a small group of people that can contribute to it and give feedback. However, later on, it becomes beta, last month actually. And everyone is welcome to change, suggest, or even fill an issue with that. Just start using it. And I'm very excited about that because compilers in general are just a very complex software that is taking some inputs and producing some output based on some knowledge. And the React compiler is not an exception, just reading your code and giving you some idea, reading your errors and telling you what you need to do better and actually producing a new version. This version is usually a lower level of your code that you don't have to read or understand. It's usually not for you, it's for the machine. And React Compiler is not an exception. It's a build-a-time only tool, that's the definition from their website, that is automatically optimizes your React application with the knowledge of two things, plain JavaScript and understand something called rules of React. These two things are the only things that React compiler is using in order to produce new version of your application, which is more optimized towards performance. The whole idea was two or more, actually, products for Meta, the company behind Facebook, that is owning Instagram.com and maybe Quest Store are the most famous one with degraded performance. And they decided to change that to use something that fixed this performance for them. And they shared in the same conference this year the results from Instagram.com that are using what's so-called React compiler for like a year right now. And these are the results. Wow, it's 2.5x the faster interactions. This is huge if you know what I mean in performance area, because if you would like to make any wins in performance, this is too hard. You need to have at least 20% faster than your last version, or at least 20% faster than your nearest competitor, so people can perceive it as it's faster. It's a 12% improved initial load time. This is huge as well. This will improve your overall core web vitals, and this will help in all cases. And guess what? The most important part, it's with 0% memory increase. This means a lot. I was really, really impressed by these numbers. And that's not me. Thank you. Thank you, Zal. But it was not me. It was them. Yes. They deserve a round of applause, because I was like that. Shut up and take my money. I am sold. These are great results. Performance is significantly enhanced automatically with no change in the code. This is huge. And moreover, 17% of the code has been deleted from Instagram.com. So you're shipping less code, shipping smaller bundles with great performance guaranteed. So this pops a question to my mind. Is React Compiler going to end the manual performance tuning era? So we're not going to do that by hand anymore? Yeah. To understand that, I'm going to step like 10 steps back and start a quick introduction about how React is working in general. React, briefly, I will be just so fast. React works by re-rendering. So every time they detect a change, they are going to re-render. And sometimes they re-render the same thing multiple times to make sure that the user is getting the very latest UI. And this is important. This is the whole idea behind React. So you click somewhere and something else happened in the screen. You might not ever think about that, how this is happening, but I'm going to explain to you. Every React component can be re-rendered in 3 cases. If its props has been changed, or its state has been changed, including context API, or if its parent component has been re-rendered, and as a consequence, all the components underneath it will be re-rendered. This sometimes can be excessive, and this is most probably why we needed the solution we are talking about today. And this is the simplest solution that we have, simplest React app, and most famous as well, that you have a counter and you are clicking a button to get the count up, clicking another button to get the count down. It's so simple, right? And can be represented in an AST or abstract syntax tree like that. It's different components, and these different components we can just find who is a parent, who is a children, and stuff. React is doing that. Find out that you clicked on something and find out where in this tree needs to be changed or updated, and re-render most of the tree in order to find out which part has been done. And this is happening, if it happens in the real DOM, imagine, that will be a problem because browsers are single-threaded, and the only thread that is able to change anything in the UI is the main thread. You can't make it even on web worker or something. This is important to know. So React is doing it in a very smart way using something called virtual DOM. I believe every one of you know that. And the virtual DOM is using something called reconciliation process, and this reconciliation process using something called fiber architecture in order to find these changes and re-render and commit. Basically, it's 2 phases, re-render phase and commit phase. And we're going to just go through that real quick. Each of these items or each of these components is considered to be something called fiber nodes, and this whole tree is called a fiber tree. So we have 2 fiber trees actually, and these 2 fiber trees, as you can see, there's one called current and another one called work in progress. The one called current is matching the real DOM in the browser that the user can see and the latest state. And the other one is called work in progress, which is watching whatever you are doing and update it and making the thing. So let's trace one step. If you would like to click on this button, which is button up, for example, and you clicked, what will happen is that it will initiate something called work loop. This work loop is starting and it starts getting instructions. Since you click on that, I just reminding you that on click it is changing the state, which means that the component has to be re-rendered. So it marks this component counter to be marked for re-render, and as a consequence, all its children has to be re-rendered. And this work loop is going to do a diffing algorithm between the work in progress and the current one, and based on that, it can see the button has not been changed, so it's okay. It will re-render anyway, but it wouldn't change anything. The H1 has been changed. The value inside it, from 0, it becomes 1. And this whole thing is happening in the memory. This is the whole idea behind the virtual DOM. Everything is happening in memory. When they detect some changes in the H1 value, it marks it as This is the part that we need to commit. This is the only thing that has been changed. Of course, for the other button as well, it re-render again, but nothing will be changed. And from this render phase, which is complex and happening a lot of things, I'm trying to simplify it. And finally, we go to the other phase, which is commit, and it is moving this cursor from current becomes work in progress. That's why they call it as well alternate. In this case, you will find that this alternate or work in progress is the one matching the current DOM and committing the only change, which is H1 to the real DOM. You still with me? Oh, it's good? Cool. Yeah, I'm happy. Moving on. Fiber is always looking for hints in order not to re-render this component. As an example, the keys. You know the keys? One of the usage in the keys, in lists, for example, you don't have to, you always get the ESLint telling you have to add a key, right? And if you add a key with index, this is a bad idea, because if you push something from the top, everything will re-render again. But if you give something which is not going to be rebated somewhere, you are giving a hint to Fiber. You don't have to re-render this component because this component has not been changed. You are giving it hints, so you save some time for performance. So we need to learn why the component has been re-rendered. To learn that, we have to have some tools. The most famous tool is React Developer Tools. Actually, it's on Chrome, it's a 5 million user. I believe it's more. And it's basically giving you an idea for each component. What's happening? How many of you are using DevTools, React DevTools? All right, there's some people are not. You really need, if you're writing React, you have to use this tool to learn what is happening behind the scenes. And you get a lot of things, profiler, and you get this highlighter where you will see what is happening, and it gives you an idea about the component tree, what is inside what, and this will be very useful in our next slides. I was going to not mention that, but actually it's very important to mention. This is a new tool, like last week has been announced. It's a React Scan created by Aiden, who created Million.js, and actually he's spamming Twitter with that. He's writing a lot of tweets about that. This is giving you a little bit more verbose way of seeing how many re-render is happening in which component, and it might be useful. It's a promising, but for me, this is giving me an idea that Twitter is very bad in performance. However, it's not, but it's a promising. It can be something in the future, and yeah, give it a try. So, well, we detected some unnecessary rendering happening. So time to fix them. React is providing something based on a concept in computer science called memoization, which is similar to memorization, but without the R. And this is providing 3 different APIs since React 16, I guess. And they are pretty useful, easy to use. I will just go through them one by one. First one is called React Memo. It's usually memorize the full component. And imagine that the same example we have before, I add only one component called my decoration image. I added Harry Potter. Any Harry Potter fans here? No? Oh my God, I didn't expect that. Okay, but yeah, anyway, we have Harry Potter here. So whenever we are clicking up or down, we are just having an image that does nothing, all right? It might be more meaningful in your project. So this will change a little bit the tree to have this my decoration beside the H1 inside another component, and this is only having one image to render this image. If we open the profiler over there to see what's happening, you will see the highlighter is highlighting each component, which is re-render, and the more the color is orange, the more it is excessively re-rendering. And you can see here, it tells you how many re-render happened during the page, and you can click on each one and find out why it was re-rendered, and so on. This is something that I don't understand. When you find out that my decoration, which is the image, has never been changed. However, React decided to re-render it multiple times. Every time you are changing something, let's see, it's 8 times re-rendered for some reason. That's why they introduced Memo. So all you need to do is these 2 things. Just wrap it inside the memo and use the memoized one, and this way it is memoized and never to be re-rendered. Just another look after having memoized, there is no highlighter around this component, means it's not re-render, and if you open this, you will find that it doesn't exist in any of the re-render now in the 8 re-renders, and here it is marked as not re-rendered during any change in the page. And you will have this tag called memo, means it is memoized, okay? Another one is use memo, and use memo is for memoizing values that are heavy computation. So if you have a value, object, or something that you would like to, a big computation like filtering or something, you don't have to do it every time there is a re-render, and React wouldn't stop re-rendering, but what we need to do is memoizing, so we make this re-render a little bit lighter, okay? As a quick example for that, we don't need to every time filter the products as long as the products has not been changed. This means that we don't have to refilter them every time. So you put it in use memo, so you use the memoized version every time without making this heavy computation. The last one is use callback, and this is memoizing any handling function. So if you just turn these functions from inside to be in the application, basically all the React components, or recently all of them are functions, basically. And so the functions, if you re-render the component, it calls the function from scratch again. And these functions for handling are not an exception. You will be recreated again. So use callback is basically memoizing this function, so you are not going to recreate it every time this component re-render. That was useful as well. So problem fixed, but seems to be a lot of work. So yeah, and some developers wouldn't be, happy doing that in big projects, and even in medium projects. Imagine about the big scales as well. If you have like I wouldn't say millions, but hundreds, thousands of components. I'm talking from experience and our work as well. So how can we fix that? Everyone would like to have performance, but no one is enthusiastic to do that work because it's a lot of work, a lot of code that you need to do. So Aliza, smart engineer, came with an idea. Could we automate that so we forget about this manual memoization forever? Actually, did that. React team announced a project called React Forget in 2021. It was during the pandemic. It's a lazy engineer staying at home, unhappy. Said, well, let's create a compiler. And he did. 3 years later, in the conference again, they announced it last May. They announced it in React Conference 2024. The same project has been a success under the name React Compiler. So it works. We are all happy here. React Compiler, like any like any compiler, comes with some caveats. You have to give a specific input. First one is valid JavaScript. Not a surprise, you have to write a valid JavaScript. Any broken JavaScript will be skipped. Another one, make sure the variables and props are defined before you use it. And this seems to be obvious as well for any React application. And the third one is use the rules of React. Rules of React is something that has been introduced as well recently, but it's not new. It's just a structure that you need to follow 1, 2, 3, and so on. It's basically 3 rules. The first rule is components and hooks must be pure. And by purity, there is a lot of things that you need to do, but basically is to ensure that your application is predictable. Whenever you are putting something or sending some input to a component, you make sure that it will get always the same output as long as the input is the same. And you are not mutating any of the inputs of the hooks and so on. Just a quick example of that, this component can be pure because every time I'm sending the same name, it will just give me the same greeting, right? If I said Africa, it will be hello Africa, and so on. This one wouldn't be considered pure because this user could be like a user service or something getting you the status. This impure because it's not predictable. Every time you're doing something in the server and it is sent here, React wouldn't know that this is happening. So it wouldn't re-render. This is impure. It's unpredictable. And you have to do some use sync featuring or something. This way you are telling React there is a change. This is important. Rule number 2, React is responsible of calling components and hooks. As I said earlier, React components and hooks are basically functions. So you are not going to do that. This is something that someone might do, that you call a function and give it the input. You can do technically, but this is something that you shouldn't do because React is declarative, and you should keep it declarative. Every time you're writing components, you write it the same way, and React will take it from there. Rule number 3 is to follow the rules of hooks, and this has been there since hooks in React 16, which is always call hooks in top level, and the other one is call hooks only within the function components or custom hook. If you follow the three of them, you will be cool. Here comes the question. What if React compiler finds that rules of React has been violated? Who think it will show an error? Who think it will show an error? The rest are absent. Okay. Actually, it would not, because the rules of React are coming to make your life as a developer easier. It's coming to make React more predictable, regardless of compiler or not. Having the fact that React compiler is using it to optimize your code is just a bonus. So whenever React compiler get a component that doesn't follow the rules of React, okay, we are going to skip this one. We're not going to optimize it, and so on. So it's beneficial for you anyway. So React compiler can actually do two things. Fine-grained memoization, regardless of what we are doing right now with use memo or use callback and so on, it can split this to fine-grained memoization again. So if you are having like a for loop or a mapping, and inside the map you are having some components, and these components you would like to use anything, like use memo or something for some values, you have to extract it in a new file, a new component, and do this memoization outside. React compiler can do that for you. This is fine-grained memoization. This is something that, as a developer, you need to do multiple steps to do, and new files and new stuff. And skip excessive calculations from outside of React by memoizing it, and so on. So let's give it a test. The same test that we had before, that we did this memoization for, that's super easy one. So basically, we need to install React compiler. It's easy. It's coming as a plugin for Babel. Yeah, super easy based on the documentation. This is my example for Vite. You just add this plugin, and it has to run the first thing with React code, so it can pick up the code as it is, and it produces your optimized code. If you would like to try it with something else like Next.js, it's even easier. In Next config, you just go ahead and open the experimentation part and add React compiler through. That's it, and there you go. React can be used right now. It's still experimentation, it's a beta, so don't use it on production or use it on your own responsibility. So the result after using it, what would happen? Yeah, as you might have expected, it's a similar thing, it's the same thing. You are getting everything has been memoized, as you can see. Everything has this label with this magical icon, means that who optimized this is React. From our side, we did nothing. We didn't memoize, we didn't create a new component, we didn't export a new one. Everything that you used to do manually is being used right now, done now by React compiler. This is really, really huge without writing any different code. So, less code to ship, that's important. Less time to review PRs, because PRs used to have this comment that, all right, let's wrap this one around use callback, or why not we memoize this one? Why you are not using the memoized version of this component here or there? That was taking some time from the developer, in addition to the time to find what is needed to be memoized anyway. Now there's something doing it for you. And finally, great performance out of the box, even more performant than what you are doing in manual memoization. So React developers right now with React compiler would be like, Harry Potter, like performance reparo to anything, and everything will be working, right? That's what you want, and hopefully something like that will be gone forever. We wouldn't have a PR just for wrapping field properties in use callback. So want to look deeper into that, I would really highly recommend this talk. It was during the conference as well, but it's a deep talk, very advanced, talking about the React compiler deep dive. That's by Satya and Mofi. They went through creating a new compiler on the stage. It's a light version of it, but it's really, really cool to watch, and it's big. It's something that needs you to watch it like multiple times in order to grasp everything in it. And just to give you an idea, React compiler is not going to code and add use memo and use callback. Actually, this is the output of this component. It's coming with totally different experience, totally different syntax. And this syntax, you can just go to Playground, to React.dev, to play around with it and see how this component is being translated. It's another way of memoizing stuff. Not really like use memo. It's more efficient than use memo, use callback, and React.memo. So feel free to play around with that if you would like. So React compiler is still not perfect, yet at least. It was experimental in React Conf in May, and 5 months later it becomes beta in October last month, and there is still 2 stages to be release candidate, and this way it will be pretty stable, so everyone can use it on their own projects. And finally, it can be generally available or stable, and this way we can use it all together on production. It's pretty nice and good and strong already because it has been used in Instagram.com, and you have seen the results. Very phenomenal. If you use it on your own projects and have any findings, any bugs, any problems, any suggestions, do now open the React Compiler Working Group, so you can go ahead to this repo and add your suggestions. There's a lot of great discussions over there that you can make use of. And here we come back to the same question we started with. Is React Compiler going to end the manual performance tuning era? As a short answer, I would say no, or at least not yet. It's going well in the right direction, and since compiler has been introduced to React recently, the compiler concept has been to all the other frameworks and libraries since maybe the beginning. Angular, Vue, Civil, they are making use of that. And React, since it is the most used library out there, deserved that from the beginning, actually. But it's not from the beginning. Now we have it. This opened the door for a lot of optimizations in the future. It wouldn't be only one or two. But if you would like to have a little bit longer answer, React Compiler is only now, at this stage, can make automated memoization, but not everything else. Everything else is still on your end. And yeah, I'm happy to say that React Compiler, of course, will end manual memoization, but not everything. This is something for granted. So what you need to optimize after React Compiler? We have quite some stuff. First one is code that doesn't follow rules of React should follow the rules of React. So what you need to do for that, they provided as well an ESLint plugin for that. They name it ESLint plugin React Compiler. Actually, it's misleading a little bit because it's not connected to React Compiler. It's just doing that for the rules of React. It should be rules, not compiler. But there you go. There is something that you can set up in your code. Don't wait for it to be built. It gives you an immediately some feedback, some errors, some warnings that you're doing something that is not following the React rules. Another thing is to use this one. It's called the Impexa, a React Compiler Health Check. This way you can run it in your code today without trying compiler. This way you can find out some report telling you how many components do you have that can be optimized if you use React Compiler and how many of them you cannot. Actually, I ran it myself on a big project that I have, and it was fantastic to learn that about 10% of our components were not following the rules of React correctly. This is important. It has some limitation, though, that some files that we have are very big files, and they have the limitation of the file shouldn't exceed the 500 kilobytes. But it's a decent thing that you can try and find out. Are you ready for that or not? There is a misconception as well that React is made for React 19, React Compiler. It's not. Actually, React Compiler works for 19, 18, and 17 as well. So you can use it today without a problem, but you need to add this runtime into your code. So if you have some limitations at your work not to upgrade to React 19, you can try it with either 17 or 18 easily by this runtime. Another thing is we need to remove unnecessary use effect. This is a really nice one. React developers like to use use effect everywhere. I would like to add it. So yeah, there is a small thing that you doesn't need use effect, but why not? I will add use effect. And finally, each click, you have 3 more re-renders happening if you find your profiler. This is too much. And sometimes, or most of the times, it is unnecessary. Okay, last month I was in React Advanced in London and had the chance to meet with Satya. Satya is one of the people who created React Compiler. And it was really fantastic talk about React Compiler. And he showed to me something very nice I would like to share with you. While they were optimizing for Instagram.com, they find out some cases that even the engineers working for Meta are doing. So look at this one. If you are scrolling in Instagram.com, if you are familiar with Instagram, if the post is a video and visible in the viewport, it is autoplay, all right? So we're not playing everything. But if it's visible, we show it and play it automatically, right? That was the code that React Compiler could not fix this extra re-render happening by use effect. So it is checking, basically, if it is visible by checking the ID of the content on the viewport to the ID that they are fetching right now. If it is so, it's visible. And this unnecessary use effect has been added to check if it's visible, all right, set the is playing to true. If it's not, is playing is false, right? I think this is very familiar with most of our projects. But to fix that simply, manually, what they did is remove all this code and only adding is playing. Okay, if the ID is equal to ID, just make it playing. So we don't have this state, and we don't have this use effect. Both of them are unnecessary. They were there, and they were stopping the React compiler from making this automatic optimization. They are following the rules of React, actually. But they cannot be picked up by React compiler. Could be in the future, but not now. Also, there is a great thread. This Dominic, he added to a few days ago about a game he played. Show me your use effect, and I'm going to tell you that you don't need this use effect. This is a great thread. I left the link for you guys, so you can check it out. People are posting some code, use effect, and he's trying to refactor it and show them that this use effect is unnecessary. Just remove it. Or in rare cases, you tell them, no, this is necessary in this case. So I really highly recommend checking this thread. It has a lot of great stuff. Another thing that you need to pay attention to, compiler works only with components and hooks. So if you have any code that is heavily using different algorithm that has some high complexity, React compiler wouldn't fix it for you. It's fixing only the declarative word. So as an example, look at this one. It's just a small thing calculating primes. And don't look at the code. It's not about the code. But this code does have complexity of big O of n square, which is too big. If you would like to optimize that, you have to optimize that yourself. You need to make this more efficient yourself. React compiler wouldn't do that. Despite you are memoizing it, yes, but still, in the first loaded list, it would take time. React compiler wouldn't pick that. React compiler doesn't include libraries. So if you are using any library and you run React compiler, and still you have some problems in performance, most probably it is the library. And React compiler encourages well the library owners or maintainers to start doing that. Some has started doing that already, but some libraries like MobX cannot for some reason. Just go and read about that. Another performance wins you can do, small ones, big ones actually, but small ones that you can think about one by one. Data fetching. React compiler wouldn't fix your data fetching mechanism, so you have to fix it yourself. Chunk sizes. That's something that you need to tackle yourself. React compiler has nothing to do here. Progressive enhancements. Whenever there is a feature supported by one browser but not supported by the other one, that's a great performance enhancement, but compiler has nothing to do for now. Virtualizing long lists. If you have a big list, you need to virtualize it yourself. That's something very good in performance, but React compiler doesn't do that for you. Managing transitions and UI priority. This is something as well React compiler doesn't do at the moment. Media, images, and videos. Actually, this is the biggest asset that you have usually in any web page. This is something that I think in the future React compiler will tackle and can do it for you, but at the moment, they don't, so you have to do it yourself. And Core Web Vitals. Just check it out and find out. IMP has been there for like a year right now. It's very important for you, for your ranking as well. So go ahead. React compiler would not do that. Of course, with fixing this re-rendering and mutating everything for you, memoizing everything for you, this helps in Core Web Vitals, but it doesn't fix it completely. And finally, upgrade to React 19. It comes with a lot of good features that you can use it for performance, and it comes with some enhancement for performance out of the box. Some stuff that will be coming out of the box, like the browser hints, now is baked inside it, like reconnect and something that you can do in your component without shipping any new thing. So yeah, a quick recap. What we did is, we have React compiler is fantastic, proven on production for Instagram.com. React does a lot of work to render UI with fiber diffing. Manual memoization is going away soon by React compiler. And it would be going away as well from the React mental model in general. You wouldn't think about that anymore. It's cleaner code. Install the ESLint plugin so you can get ready from now. This is important and useful for your code anyway, even if you are not going to use compiler. This is useful to make your code more readable and more future-proof. And finally, performance optimization efforts it might be reduced using compiler. That's a fact. But the performance is like a moving target. The more you're adding code, the more you would like to introduce performance issues. So please keep measuring and keep fixing stuff. I left here some resources for you, so you can read more about that. It will take some time to sync for everyone, so please watch it in your own time again. Thank you very much. If you would like to watch my... Thank you. 2 more words. If you would like to see this slide, it will be shared soon on my website, and medhat.dev, and feel free to reach out to me on Twitter if you have any question, or come to me later. There is 2 QR codes over here. You can scan, one for my LinkedIn, one for my Twitter, so please scan it later, right? Thank you very much.
Thank you so much, Midhat. Thank you. And now, I will introduce our final speaker. She is the most known Moroccan woman in the Italian tech community. I was there in Milan. I met her first there in Milan, and they told me that if they have a conference there, the first speaker that should speak is her. And when she is speaking, there is no other track. Only one track, she speaks, and after that, you can have 2, 3, or 4 tracks, okay? So, I introduce Soumeya Radi!
All right, thank you. Hi, everyone. Are you enjoying the conference? Oh, it's not a nice answer. Are you enjoying the conference?
فيقوا معنا. فيقوا.
Are you enjoying the conference? Yes. So today I'm talking about testing. It's not like the best to end with, but it will be fun. So before I will introduce myself, my name is Soumeya and I'm from Italy. I work as a senior software engineer at Atlantis, that is a small company in the north of Italy. And I work mainly with front-end, so front-end stuff with some blockchain. And yeah, I enjoy everything that is technology, from like electronics to IT. And I like to speak at conferences, so you can see me around a little bit during the year. So testing is not like my favorite, and I think that every developer hates testing. Who loves doing testing? Nice, nice. So for testing, actually for me, it was like a nightmare at the beginning because I didn't like write tests because I enjoy doing tests, but like my company was telling me to do tests. So it wasn't like the best, but I've seen with experience that maybe sometimes we are looking for something that will ensure that the quality of what we are delivering for our users is like the best. So testing do that. So ensure that everything that we have developed is like the best suit for our use case. And in particular, I've tried multiple types of testing. I didn't like unit tests. I try to do component tests if I have like complex components to work with, but the ones that I really enjoy and I find like for front end a real use case that is actually helping me is end-to-end testing. End-to-end testing for me is fundamental because it will verify 2 things that for me, for my application, are like really important, that are the functionalities and the performance of my application. So I want all the functionalities that I've implemented in my application are actually there, and the user can use that. And also like the performance, so the user experience is like the best. I want like the user to enjoy using my application. So for doing end-to-end testing, we are using some automated UI testing, What does it mean? It's something that actually is going to replicate some user operation in my application. So I will write some code just to make sure that all the user experience that I want in my application, it will be replicated in a faster way, and I will be sure that everything is working fine. So for years, Selenium was like the number one. It was like the first one coming up as an open source tool, so free for everyone. Everyone can like use it without like spending money. So it was like the best choice because it was the only choice for years. And then now we have like some competitors. And in particular, today, I want to talk about these three because I think they are the most popular ones and are all open source or free to use, and are the three that I've been working on in these 10 years of my experience. So I started with Selenium at the start, and then I passed to Cypress and Playwright. So let's see them. I will start with Selenium because it's like the oldest one. Selenium was released in 2004, so like 20 years. So it's like the most used one because, not because like it's the best, but because it has been there for a long time. And also like if you have like big projects that are like out there for like many years, you usually have already Selenium there and you still work with that. And actually, if you have like big projects, it's difficult like to pass from a framework to another. So Selenium was released in 2004 by this guy, Jason. Fun fact, the name Selenium was chosen because of a fun history. There was, at that time, a big framework that was called Mercury Interactive. That was a really expensive tool to use for testing. It was like the most popular one. And he actually didn't like to pay a lot of money for that. So he wanted to make a framework that was open source, so free for everyone. And he called it Selenium because Selenium, the element, contrasts the poisoning of mercury, the element. So he called it Selenium as a joke for the most expensive one out there. So Selenium, how it works works outside the browser. So we have these drivers because at the beginning, Selenium wasn't really the best. It took like 2 or 3 years, and they developed this Selenium WebDriver. At the beginning, it was called WebDriver, and then they implemented it into Selenium, and it's called like Selenium WebDriver. So now when you use Selenium, it's actually Selenium WebDriver. And it actually have some drivers that communicate with the browsers. So they work outside the browser and are actually interactive, and we can interact with the browser with the use of them. Selenium has a great support for programming languages. So it's actually really cool because you have like support for any language that you want for end-to-end testing, but also like other kinds of testing, but we are like concentrated into end-to-end testing in this case. And also has browser support. So you can use it on Chromium, but also in Firefox and WebKit. So big things about Selenium. The pros are like language support, browser support, and you have community support. That they have a large community that are really helpful, really enthusiastic about this framework because it was like out there for 20 years. So many people know how to work with that, and they are really active in the community. Not so good things about Selenium. It's a little bit slow, in particular, like compared to the modern frameworks that we can actually use. It has this flaky test problem. It was really popular for Selenium. It means that sometimes the most popular use case is that sometimes it tries to interact with some components in our application that are not rendered yet. So you get like an error, but it's not like actually an error because probably he's trying to click on a button or writing on an input that it's not rendered yet. So it's not like an issue because it's not a real a real problem of our code, but it's a problem about the tool that is not waiting for that component to be rendered and ready to use. So sometimes you need to manage that and add like some waiting, some sleeps to make sure that the elements are already rendered and ready to be used. And the setup is not that easy to implement at the beginning. For like beginners, it's not like the best, in particular if you have like big projects. So let's see a little demo to see how it works actually. Oops, no. No. Okay, so here I have a really simple, it's just like JavaScript and some HTML. It's a simple calculator. I will run it just to show you how it works. It's just like 2 inputs, and I'm doing like, if I add 10 and 5, I can add and have like the result and subtract and get the result. It's really simple, but let's try to replicate what we are doing into the interface by code. So here, what I need in my application is just to install the Selenium WebDriver package. So we need Selenium WebDriver, and then we are ready to use. We need to implement some tests, and we have like this 5 tests. And as you can see, it's just like a function. It's a function that does something. So we have our WebDriver, because we need the WebDriver. So from Selenium WebDriver, we need this builder that will create a driver for us. We are going to build a driver for the browser Chrome, because we want to use Chrome in this particular case. And with build, we'll create this driver. So the driver will do the work for us. Once we have the driver, we are going to the actual URL of our web page. In this case, I'm in localhost 3000, and I'm getting the element. So I'm finding the element that has ID number 1 and ID number 2, that are the 2 inputs. And then I'm finding the add button, and I will click on the button. So I will write the numbers in the inputs. I write 10 and then 5, and then I click on the button. And I want to find the result. So the string that will appear, the result 15, I want to get this result. So I will compare the result with something that I know it will be right. So I want the result to be result 15. And in case of not getting this result, I need to add an error message in this case. So I will add the message, addition test failed. Same things for the subtraction. I'm getting the result. I want to compare this result with the one that I'm getting from the application. And in case of failing, I'm getting subtraction test failed. It's a function, so it will run one by one every steps. So if the first test will fail, it will not like continue to do the other tests. It will stop there. And this is not a good thing. So let's run this and see how it works. So I'm running this test. And as you can see, it's super fast. You will not see anything. So I will slow down a little bit, adding some sleeps, just to show you how it actually works. This, I will run it again. As you can see like the interface. He's writing the 2 inputs, 10 and 5, clicking on the button, getting the result, clicking on the other button, and getting the second result. And here in my console, I will get the all tests passed. But in case I make an error, for example, here I want to result 13, it's not correct. So here, if I run it again, I will get test failed, addition test failed. And he's not running the other tests. So it stops there because it's like a function. So it will not like go through the other ones. If we want to see really, really fast some extra things that we can do with Selenium, we can use like screenshots. So in case of failure, I can like make Selenium do a screenshot of the web page in that particular moment. So I will get like an easier way to debug what's going on in this case. And also I can use this headless mode. Headless mode, it means that I don't want my browser to open because I want it to be faster. So if I want to be faster, I will not make my browser open and I can go headless in headless mode. And I will add it in my Chrome options. That is, when I build my WebDriver with the builder, I choose Chrome. And in Chrome options, I can add this headless mode. And this will run in the background without opening my browser. And I can do like some tests. And in case of failure, I can do a screenshot. So let's try to run this one just to show you. I will make an error just to see the screenshot. Here result, for example, 7. Okay, I need to run the advanced one. Here, so it's not opening up my browser because it's not open, but it actually runs all the tests. And the last test is test failed, subtraction test failed. And I want to see if it took the screenshot. As you can see here, it creates a folder screenshots for me. And here I have like a screenshot of the web page in that particular moment. And as you can see, I have results -10. And in my test, I did -7. And that's what the case that's actually failed. So yeah, this is like Selenium, how it works. It's like a function, and everything will run consequently. Let's move on to, to Cypress. Cypress is the first real competitor to Selenium. It's actually arrived 10 years after Selenium in 2014 by this guy, Brian. He was a developer, and actually he was really annoyed about Selenium because like there was just Selenium out there. He was working with that. He wasn't happy. He was really not enjoying using Selenium. So he wanted to build something that was actually nice for developer to use. So his like must thing was like to have the best developer experience ever. And he actually built Cypress a little bit different from Selenium. He was like really concentrated into 2 things to make it like works in particular for end-to-end testing. So it's really specialized in end-to-end testing, also component testing, but it's more used for end-to-end testing. And it actually works just with JavaScript. So we are in a particular environment with JavaScript and TypeScript, of course, but he wanted like to make sure that you are using this tool for a specific use case. And it was actually built for that case. So good things about Cypress is the developer experience. It's actually great. We have automatic waiting. Automatic waiting, it means that Cypress will actually wait for the elements to be rendered until it actually interact with them. So we'll not have like that flaky test that we had like with Selenium. And we have error reports. So we don't have to add an error message after every test because Cypress will handle that for us. Not good things, we need some extra plugins if we want like to do something a little bit more complex. We have limited browser support because it works just on Chromium. So we have a really limited, but also like really specified. It's only JavaScript. It can be like a cons, but also like a pro for me because it's really specific. And he wanted like to make sure that they are, it's like the best for the modern web framework out there, like React and Angular or Vue.js. So let's see how it actually works. I will do the same demo, but in this case for Cypress. So here we just need to install Cypress. And we have like some configuration already done for us. So when you install Cypress, you will get this Cypress config already like created from like the CLI, and you have like just the base URL and some fixture if you want like some fixtures, and then you have like this folder Cypress that has end-to-end where you will add all your tests, and this file support where you can add like some plugins, or if you want like some extra commands, some custom commands that you want to add, you can add it in this command file. Let's see like the same demo as before. In this case, we have like some another type of writing tests. We have like tests that are individual, so every test will run separately one from the other. So in the first case, we are doing the test for the addition. So he will type the two numbers, click on the button, and make sure that the result is correct. If it's correct, it will pass. If it's not correct, he will handle the error for us. So in this case, I want like to make it not work. So we'll see if the second test will run, even if the first one is actually failed. So I will try to run this, and I will run it with the UI, because we have this nice UI from Cypress that is really helpful. I'm doing end-to-end, and I'm using, it's not running, okay. So I need to run the application, and then I will open this end-to-end. I want to use Chrome. And here I will have like, he will find all the test file that I have in my application. In this case, we have like calculator. And as you can see, it will run, and we can see on the left what is going on. The first test is failed, it's red, but its second one, it's actually passed, because he actually ran the other test. It will not stop when the error is, it will continue to run everything else. So this is passed, and as you can see, you can actually explore it actually happened. So by hovering into the steps, you can actually see what happened in your application. And in this case, in case of failure, as you can see here, it actually clicked on add, the result was 15, and here I have this error that has, I was expected to have result 13, but the text was result 15, and it will indicate also like the line of code where the error is. So it's really easier to debug in this case. Okay, so with Cypress you can do a lot of other things. I will like leave you the code if you want to explore more of that. Let's go to the last one is Playwright. Playwright is the younger one, and it actually came in 2019, 2020, and it was developed by Microsoft. It's a Microsoft product, and even if it's really young, because it's just 4 years now, 5 years, but it's actually growing so much. Actually, the developers that have created Playwright, before they were working for Google with Puppeteer, but Puppeteer works just on Chromium, and they wanted to make it a little bit more inclusive for browsers. So they wanted to test also like on Firefox and WebKit. So they left Google and joined Microsoft that helped them doing this tool. And it's actually it's pretty much similar to Selenium. They have some similarities to Selenium. We have a real great support for programming language and also for browser support, because they have been built for working from Chromium, Firefox, and WebKit. We have headless mode. Headless mode have been implemented in the last few years, and then like Selenium had to stay up to date. So in Selenium has arrived actually really late. And really nice about Playwright, it actually supports mobile emulation. So we can actually test on mobile and have all the features about like mobile and test everything. Not that good about Playwright. It's a little bit complex to work with, because they have like these APIs that works outside the browser. So for beginners, maybe it's not like the best because also the documentation online is not complete, let's say. The syntax is not that intuitive, but it's really like if you have the opportunity to work with that, it's actually a really good tool. And the community is small, but it's just because it's not out there for a long time, so it's actually going there, but the market, it's going through a good things about Playwright. So let's see how it works. So we have the same demo, but in this case, we are using Playwright. We can use Playwright as it is with other testing frameworks like Jest or like Mocha or Jasmine, and we can use the functionalities of Playwright in some tests that we already know how to write, or we can use this Playwright test that is like the suite of Playwright, and it will actually create this Playwright configuration. And here you can add a lot of stuff. You need to, the most important things are like this test directory. So you need to make sure to indicate the directory where your tests are. So in this case, I'm using this folder tests. The timeout, so how much time do you want your application to, do you want Playwright to wait until getting an error in case if it's not working? The number of retries, if it's not passed, if you want to retry to run the test. And then like the base, sure, if you want like to make some screenshots, the headless mode, the videos, a lot of stuff. And also like if you want to run on different browsers, in this case, I've configured the 3 browsers, Chromium, Firefox, and WebKit. So if I will run Playwright, it will run on the 3 browsers, and I will get like the answer of everyone. And then here I have my my tests. So it's similar to Cypress, the way that we write tests. And as you can see here, we have like a single test for everyone. So everyone will run separately, and it will not like stop after a test failed. And another thing that we can configure is how we want our tests to run. If you want like to run one after the other or like in parallel, you can like run all the tests in the same time. And this is like making testing really faster because you will get the answer in less time. So let's try to run this. You can run everything in the same time for the 3 browsers, or in this case, I will run just for Chromium. I will run everything, so you can see that it will open up the 3 browsers, and it will give us the answers for that. So it was 2 tests for every browser, so I have 6 tests passed because it's for the 3 browsers. And here, as you can see, everything is passed, but I can also make something not work, just to show you how it actually is working. So here I have this one. I will make this like 12, okay? And I will run it again. And yeah, it's broken for 3 because like it's run on the different browsers, and as you can see, you have like the correct line where the error have been made, and it's really easy to debug also with this, and it's actually really faster than Cypress. So, okay. So last thing, we were talking about what is the best. So which one of these is the best testing tools? So the right answer is always, it depends. So we can do some consideration. So we can talk about Cypress and Playwright are really becoming really popular lately because are the youngest one and they work really well. And they have been used a lot in the last few years. As you can see here, like in the last year, the green one is Selenium WebDriver, is still used a lot, but Cypress is used way more. And as you can see, Playwright is the youngest one, and it's actually growing a lot. It's actually reached more than 7,000 now. So it's actually growing a lot and has a great potentiality from that. If we want to compare these two, Cypress is more like a package. So we want to test in a particular environment. So we are like JavaScript, Chrome, and we need like a certain like ecosystem. In Playwright, we have like more freedom. We can choose like the browser, and we can choose like also the programming language that we want to use. Cypress run with Mocha as testing framework. So under the hood, we have Mocha running. With Playwright, you can use Playwright with Mocha, with Jest, or Jasmine. So you can use it with more freedom, let's say. Cypress and Selenium have a strong community because they have been there for a long time, so you can find a lot of documentation, examples online. Playwright is just too young, but still you can find a lot of people working with that and also like promoting a lot this tool. If you want to use this, they are fine, all the three of them, for small or like large project. But if you have like more complex projects, I don't recommend to use Cypress because it has some limitations. For example, it actually works inside the browser. The other two works outside the browser. So you have a little bit of limitation of how much you want to test in the same time. With Cypress, you can just test one tab at a time. You cannot like test on multiple ones at the same time. So Selenium and Playwright are better for that. And if you work with JavaScript, you should like test with JavaScript technologies, and Cypress and Playwright are great options. Cypress is just JavaScript, so it's specialized on that. Playwright is a Microsoft product, and Microsoft, they have like support for TypeScript, so they actually work with that really well. And if you are working with a Microsoft stack, you need like to test with Microsoft technologies, and in this case, Selenium and Playwright are like ideal. So yeah, here you can find the demo with other like advanced tests that we couldn't see live, but the code is open. You can actually work with that, play with that, and if you have like anything that is not working, you can reach out. So yeah, this is me. Thank you very much.
Thank you so much, Soumeya. شي داز مزيان تبارك الله عليك. React Africa is over. J'espère que c'était une très belle journée pour vous. قلبت الفرنسي, c'est bon, j'ai fini l'anglais que j'avais toute la journée. Next slide. Many thanks to B2 Solutions for their support, and also for Joranosaurus Tex for their support also, for Forkit, Beer Studio, they are here, the Tunisian guys, friends of Ayman, freestyle, you see. Thanks a lot for the partners also, and now we have a ticket to win to attend to React Paris. I was there in React Paris last year. It was really, really great. Great conference, a lot of people, good food. I love the food. And another things there than foods, you will find some things that you didn't find today here, with fromage or birret. هادشي اللي كاين. انا نخلي دابا ايمن يدوي باش يشرح لكم.
Yeah, okay. So First of all, I would like to thank everyone for being here, be it the speakers, the tech team, the venue, the attendees, of course, and our partners for Kit. Thanks a lot for being here. So our next conference will be React Paris. It's going to be a 2-day conference with some awesome speakers such as Kenzie Dodds, Tejas, Dominic from React Query, Aurora, and Katrina. It's going to be an amazing conference. We're going to experiment with a new format where we will have way more deep dives in the morning and a bit more interactive sessions in the afternoon with panel discussions and shorter talks. And like when we created this community BGS, we wanted community to get together. And we know that, for example, for Moroccan people, it's very difficult to be able to go to a conference in Europe and Paris. And that's why a few weeks ago I posted on LinkedIn that we will be offering not only a ticket to React Paris, but a full paid trip to go and attend React Paris. And so I said that people need to be attending the conference and stay till the end. And also there was some reposting stuff and all. And so, who can I choose to get a number from 1 to 12? Johan. A number from 1 to 12. 9, okay. Let me see. Who is it going to be? 11, 10, 9. Okay. So the winner of the fully paid trip is Yusuf Al-Azizi.
سبحان الله العظيم سبحان الله العظيم كنت حداه الربح قدام الربح ولا لا
شكرا صراحة Thank you, Ayman, for the gift, and thank you for bringing all these amazing people to Morocco. Welcome all, guys. So yeah, I will be happy to be there, inshallah, next March. And thank you again for the conference. Thank you.
Yeah, again, thank you everyone for being here. Thank you, Ayub, for the amazing emceeing, the dance, the singing, everything. Moroccan couscous is way worse than Tunisian couscous. Tunisian couscous is way better. And I will prove that, because I will make React Africa one day in Tunisia, and you will be all invited to Tunisia to join. And so now we're gonna end. Oh yeah, I forgot. Thanks a lot to the volunteers for their amazing work. And we usually end our conferences by just taking a group photo together. So if you would like to, let's get together and take a photo. If you don't want to, it's also fine. So thank you.
زيدوا ما تحشموش زيدوا قرب القصاري جلسوا اللي متوسطين يوقفوا هنا والطوال يرجعوا للور انت جلس انت غا جلس انت قصير بحالي يلا اللي ما لقاش كيفاش يجلس يدير بحال السيليبرا ها شوف فوالا جلسوا بحال هكاك الله يرضي عليكم دوز نتانا يلا يلا اسمح لينا الشاف بلاتي واحد الدراري باقي معطى الدراري درويش ديال الكوميونيتي تا هو والله مسكين اجيو التيم دراوش اجي انت انت كتجري يلا واحد جوج ثلاثه
واحدة سيريو وواحدة تعب
دابا خسروا وجهكم، يلا خسروا وجهكم ديروها. سي بون، يلا نوضوا على سلامتكم. الله مولانا يا ربي، الله ييسر لكم الامور وبنادم ما تقطعوش التران ديال دابا، خلو تركب فيه انا. يا ربي نلقاو عامر ما نلقاو فين نجلسوا، ولا وصل التران. الله ييسر الامور، الله يحفظكم. العام الجاي ان شاء الله. كسو ديال قبيله ولكن يكون احسن.